When you think about planetary imaging, you think about Jupiter, Saturn, possibly even Mars. But this video, I'm going to give some attention to a planet that doesn't generally get too much of it, and that's Venus. Probably the main reason for this is the fact that Venus is boring to look at. Apart from seeing the phases, it's effectively a white blob. Even as a stacked image, it's pretty basic to look at. Especially when we compare it to photos taken by the Mariner 10, the Pioneer Venus orbiter, and of course probably one of the more famous ones, the Hubble Space Telescope, which was taken in infrared. We don't tend to see that level of detail. This is basically what you can expect to look at through your own scope. So fortunately for us, we do have a secret weapon. The use of IR pass filters and what's called a U-Venus filter, which is basically lets through the ultraviolet light, filters out everything else, and the infrared lets through the infrared and blocks out everything else. We are able to capture detail on the surface, or at least in the atmosphere. You'll notice in the imaging train, I've got the camera, the SV Bonnie 705, which is the IMX 585 sensor, a filter drawer to swap out the IR pass and the U-Venus filter, the Sun Observer ADC, but there's no Barlow. Now this is because the U-Venus filter is so dark that by adding a Barlow and increasing the F ratio, I can't get enough light in. We can't get enough, the camera speed, the frame rate, can't get it high enough to really embrace lucky imaging. So I ran it at native focal length, which is 2800 millimeters. So I set up the C11 on the first night, and as you can see, Venus is right next to Jupiter, and they're very, very low on the horizon. Now with the IR pass filter, it looks like boiling, bubbling water, and you can see the U-Venus filter, the gain's been turned right up. So here's the IR pass, here's the stacked U-Venus filter, and then when we merge them both together, it looks like a horrible blue-green blob, so not really much better. So this is where I worked out something wasn't right.
You must collimate, my apprentice.
So when I defocused on Venus, I noticed, as I zoom in slightly, the center ring is sitting slightly to the right-hand side, so collimation is actually a fair way out. And when I zoom back in here, you'll see we're getting a real blurred boiling effect. So I removed the filter, actually pointed it towards Jupiter, took it out of focus again, and played around with the collimation for a little bit till I got what I thought looked pretty good. And I've moved it back to Venus, refocused it, and took some more lucky imaging videos with both the IR pass and the U-Venus filter, and then I've stacked them. So here's the IR pass, and excuse the fact that the camera got turned upside down, but you can see the video is a lot crispier, a lot less like a boiling atmosphere, and you do tend to see sort of every now and then the perfect outline of the phase of Venus. And here's a video capture of the U-Venus filter. The speckly noise looks absolutely horrendous because I've got the gain set so high. The U-Venus filter is extremely dark, so it doesn't let a lot of light through, but this will come out later in stacking. So here's the two side by side, the infrared, the U-Venus filter. Now these are the stacked images. And once we add them both together, this is what we get. You can actually see very faintly the cloud structures of the atmosphere of Venus. A lot more exciting than looking at the traditional white blob. On the second night, I moved the scope up onto the veranda because it was freezing, and I wrapped some thermal cell blanket around it. Now, this is the C11 that I've just purchased secondhand, but I'm going to do a video on the C8 versus the C925 versus the C11. So keep an eye out for that. In the meantime, this is the image from the second night, combining the IR filter and the U Venus filter. So thanks for watching, guys. Let me know what you think. Leave a comment, and I'll see you on the next one.